Today will be the first class, okay, first class of Docker. And before starting the session, I just want you to show the tools cycle, okay. So first we will start with Git, okay. Once Git is completed, we will go to Ansible, okay. Once Ansible is completed, we will go to Docker. Once the Docker is completed, we will go to Kubernetes. Once the Kubernetes completed, we will go to Terraform, okay. After Terraform, Jenkins, okay. After Jenkins, we will discuss some real-time projects and a monitoring, how to monitor this total. Once the setup is ready, how you will monitor, okay. Then after again the cycle will continues: Git, Ansible, Docker, Kubernetes, Terraform, Jenkins, projects, and monitoring part. Some people will might join in between, right? Right now, like Jason, you have joined from Docker. Okay, it is there is no link. Okay, but there is a link between this Docker Kubernetes. So if you join from Docker, right, for next 20 days, nothing but for next 1 month, no one will be invited in between. So yeah, from Terraform, definitely some people can join. But once you enter Docker in Kubernetes, no one will be allowed, because if you know Docker, then only you can understand this Kubernetes. So this is the cycle which I follow. Okay, and as we completed Ansible last week, now we are starting this Docker. Okay, so before starting Docker, I just want you to show the calendar. You need to know the clarity, right, when the tool is starting, when the tool is going to end. Okay, if you see, Docker is starting today, that is 27th June. Okay, okay, and it will end at 10th July. Once the Docker is completed, we will start Kubernetes. Kubernetes will start from 11th July and it will end at 24th July. Nothing but in next 1 month we will only focus on Docker and Kubernetes. Once the Kubernetes is completed, we will go to Terraform, that is from 25th July to 4th August. Okay, Monday to Friday you will be having classes. Today is Thursday, right? Friday. Saturday and Sunday you will be having a time for your practice. So this only 2 days you will get a time to practice. Utilize these 2 days to practice. Then after remaining Monday, Tuesday, Wednesday, Thursday, Friday, regularly we will be having classes. On weekends you will be having holidays, so that you can able to practice. I am giving 2 days of holidays only for practice, because if you don't practice, it's a waste of joining this DevOps. So that's the reason I'm giving some time. But if you know already, in my sessions already working employees will join. I know they will not have time for practice during working days. At least these 2 days they can easily practice of 5 days of session. Okay, and it will daily 1 hour of session will be there. So if I start at 7 a.m., I will end at 8 a.m. For me it 1 hour, but for you it will be 3 hours, because you need to practice. If you don't practice, don't join. Okay, I hope you got clarity about what is the tools cycle I will follow. And okay, and today I'm not discussing any demo and all, so I'm directly starting the Docker. Okay, if you want a demo, I will share you the link. Please go through that demo video, because I don't want to waste the time. So I will directly jump into this Docker from today. So before going to Docker, I just want to show you the definition of Docker. You will not understand, but I will show you it again. If you say, just read it, what is Docker? Imagine Docker as a magical container for your computer programs. Okay, let me zoom it. Imagine Docker as a magical container for your computer programs. It's like a virtual box where you can pack everything your program needs to run smoothly. Okay, imagine Docker as a magical container for your computer program. It likes a virtual box where you can pack everything your program needs to run smoothly. Nothing but he is telling Docker is nothing but a magical container for your computer program, nothing but for your computer software. Like for suppose there is a Chrome browser. This is also one application. So what he is telling, it likes a virtual box. Okay, where you can pack everything your program needs to run smoothly. Nothing but this container is nothing but a box where you can pack this Chrome browser to run this Chrome browser smoothly. That this includes this program itself, its code, libraries, all the necessary files. Nothing but in this box, whatever required for this Chrome browser to run, everything will be already available. Okay, once you have packed everything into the container, you can take it anywhere you want and it will work the same way on any computer that has Docker. Nothing but what we are doing, rather than running my Chrome directly on my Windows, what I am doing, I am keeping this Chrome browser into a separate box and I am copying, I will take that box into multiple systems where Docker is installed, so that it doesn't matter where you are running. I just simply copy that box into multiple laptops. There I need to install Docker software. Then automatically my Chrome browser will work anywhere. That's what here mentioned. Don't worry, I will show you the slides as well. In simple words, Docker helps make sure your program works the same way on different computers without you having to worry about compatibility issues. It's like putting your program in a special box that can run anywhere, making it easier to share and use by others. Okay, now I will show you the same image after my slide presentation. Okay, or let me open this slide. What is Docker? Am I audible, right? Is there any disturbance from my side?
No problem.
Okay, thank you so much. So let's say you have created an application, nothing but you have created your own Chrome browser, and that's working fine in your machine, nothing but in your laptop. Okay, just imagine that your laptop is a development, your laptop name was development. Now what you have done, you have copied your Chrome browser to your friend's laptop. Okay, but in your friend's laptop, that is your friend's laptop name was production, but in production it doesn't work properly, right? Now there will be a fight between your friend and you. Your friend will tell that your Chrome browser is not working for me. You will tell that no, my application is working like my Chrome browser is working for me, but why it is not working for you? So in between there will be a fight. So what is the reason it could be? It could be a dependencies, right? It could be a different versions. It could be a framework. It could be OS level features. Like for suppose you are like working on Windows 11, your friend might have Windows 7, right? Windows 10, OS level difference might be there, right? Same laptop, you will be running same laptop, but they might be have different OS, different versions. Okay, and dependencies also, it might, but as your OS changes, automatically dependencies and versions will, frameworks, everything will be changes. Okay, so that the developer machines has but not there in production environment. So what are the operating system which you are running that might not be present in your friend's laptop? Okay, so we need a standardized, then Docker came into this picture. We need a standardized way to package the application with its dependencies and deploy it to any environment. Now I want a tool which it should package my application with the dependencies, nothing but whatever required to run that application, and it should deploy it, nothing but it should work on any laptop, not only my friend's laptop, anywhere in the world it should work. So Docker, what is this Docker? Docker is a tool designed to make it easier to create, deploy and run applications by using containers. So Docker is a tool created to run your application easily on any environment, that too by using a container it will run. What is this container? That is a secondary part, we will learn. But what's the use of Docker? Why Docker was created? You just understand, that's it. How does Docker work? Docker packages an application and all its dependencies in a virtual container that can run on any Linux server. Nothing but it will take the Chrome browser, it will kept into a simple container, and using that container it will run anywhere over the world. The only thing you need to do is you need to install Docker on that particular server where you want to run the application. That's it. So each container runs as an isolated process. Okay, each container runs as an isolated process in the user space that take up less space than regular VMs due to the layered architecture. It is telling whatever the laptop you are work right now you are running the application, compared to the normal laptop, this container will take less space compared to the original laptop where you are running the application. Super, it's an advantage, right? It is taking the less space, less CPU, everything will be less, so automatically people will prefer it. Even though it is a magical box, it is taking less space compared to original system, so it is beneficial for everyone. So it will always work the same regardless of its environment. Okay, now now I will show you this, what is Docker.
Excuse me, sir. I have a question before you proceed.
Let me show you, then I will give you some time. Okay,
Can you hear me? Hello.
yes, yes, I can able to hear you.
Okay. I
Let
have a
me complete
question
this
before we.
image.
Oh,
Let me
okay.
complete
Okay.
this
Sure.
image,
Thank
then
you. Mhm.
okay, now I will read it again. Imagine Docker as a magical container for your computer programs. It's like a virtual box where you can pack everything your program needs to run smoothly. This includes the program itself with its codes, libraries, and all necessary files. So once you package everything into the container, you can take it anywhere you want and it will work the same way on any computer that has Docker. In simple word, Docker helps make sure your program works the same way on different computers without you having to worry about compatibility issues. So there will be no compatibility issues because it's running on a separate box, so you will not get any issue. It's like putting your program in a special box that can run anywhere, making it easier to share and use by others. Okay, now you can ask.
Okay. My question is like this Docker is an application, right? So it can only run on Linux, or can it work on Windows or Mac PCs and stuff too? Because you are referring to laptop, like do we have to have a laptop with Linux in that, a separate laptop for it, or it does work in all kinds of laptops with the other operating systems as well?
Yeah, Docker container is nothing but a Linux kernel. So obviously
Okay.
you can treat it as a Linux.
Okay.
You can install this Docker software on Windows, on Mac as
Mm-hmm.
well, but
Mm-hmm.
companies prefer only Linux operating system. Even though
Okay.
if you are working running in the Mac, in the back end it will take a virtual box, it will run on the Linux itself.
Okay.
It will show like you are running the Docker container, but in the back end it will utilize the a virtual box which
Linux.
is a Linux.
Okay, got it. And one more doubt is like we will be working on so many applications now as we are doing DevOps. So my question is only GitHub. I know it is free, but how about like Docker and other applications that we use? Are we gonna subscribe to them, or they are free applications? Do we have to install these anywhere or something like that?
Yeah, that thing we will be discuss. It's a future topic. You no need to worry.
Mm-hmm.
Yeah, you can
Okay.
able to practice it. You need to
So
have an account
now,
in cloud. That is in
oh,
any
okay.
of the cloud. It might be
Mm-hmm.
AWS, it might be Azure or Google Cloud. You need to create an account in any of
Mm-hmm.
this s- cloud. There I will show how to install this DevOps tools and you can practice.
As of now, until the training is happening, we don't need any specific features in our laptops. Regular laptop works fine for and throughout the entire course. Is what you mean,
Y-
right?
You need to create an account in AWS or
Okay.
Azure or
Yeah.
Google Cloud. That account is needed.
That's
You will do everything in the cloud.
okay. So nothing to worry about what kind of laptop I am using now, right?
Yes, yes.
Okay. Thank you. That's what I needed. Yeah. Thank you.
Okay. You got like everyone, you got clarity, right? What is this Docker? Why we use Docker? The purpose of Docker. I am not
Yes. Yes.
asking
We
you
understand.
what is this container, what is this box. I'm not asking. I just asking you. You understand the concept of what why Docker came into this world, what it is resolving the problem. In the interview, if they ask what is Docker, at least you can able to tell them in your own language what is the help of Docker. Satish, you got it right?
Yes.
Okay, okay. Others? Venkat, Surendra.
Let's go.
Okay, sir. Gopinath, Manjunath, thank you so much. Okay, let's continue. Now, I already shown you the slide. Okay, before discussing Docker, we need to discuss about different generations of application. Like in olden days, how companies used to run the application. We need to know, right? So let me open this day one slide. Okay, let me go to the first slide. Generations of running applications. So what application will do? Application bring revenue. To make application run, we need servers. Now you are using Paytm, you are using Google Pay, you are using Phone Pay. So what are the application you are using, right? That application will brings revenue for that particular company. So no one will give service for free anywhere in the world. If you are using Phone Pay, they will charge you a platform charges. So now Phone Pay will be used by millions of users. So obviously you can count how much revenue they will generate. So but at the end, to make application run, we need a server, nothing but a laptop. Where I will run my application, I will run on the laptop itself, right? But in software world they will call it as a server. In my laptop I am running everything, right? Chrome browser, right? Now slide everything, but in server is nothing but a separately created for only to run the application. That's the reason it is called it as a server. So there are three major generations of running application on servers. In this also there are three generations are there to run the application on that particular server. So this is the sample application architecture. You even don't understand, it's okay. Whenever you visit any website in your browser, the request will go to your web or application server. Okay. So like for suppose you have visited amazon.in and you are login with your Amazon Prime username and password. So it will go and check in the backend database whether your username is correct or not. It will check in the backend database and it will you will get a reply. If you entered the correct username, you will log in into that website. Okay, you can shop. If it is not wrong, if it is wrong, it will throw an error to your browser. Okay, what is this? This will thing, these things you will learn. Okay, don't worry. So generation one, run directly on physical server. What are the steps involved here? So first thing, you need to go to the market and purchase a physical server. Okay, it obviously it will cost involved, right? First you will go and purchase a physical server. Nothing but then after you will install operating system. Nothing but you operating system will not be free. Obviously you need to, there will be a licensing cost will might be involved. On the top of that operating system you will install your application and the necessary softwares. This is the process used to follow in the generation 1. Okay, they used to purchase the physical server, then they used to install the operating system, then after they used to install the application necessary softwares. So what are the problems came in this generation 1? In the case of under usage, hardware resources are wasted and return on investment will be under question. So simple meaning. Okay, now during Amazon Great Indian Festival, I will be having huge hell lot of users. So what in generation 1 they used to do, they used to imagine that I used to get a too much of users, so for that before itself they will purchase more physical servers because I will be getting multiple visitors, so that I will get a huge money. They will just use it to imagine like that their application will going to work and they used to generate a income. So in case of under usage, nothing but if there are no visitors in your website, hardware resources are wasted, right? What are the hardware resources, extra hardware resources you have taken, it will be wasted, and return on investment, nothing but whatever the invested you have, what are the investment you have kept, it will be a question mark because I am directly going to the market, taking the physical server and installing my operating application, and I am just imagining that my application will going to use by multiple people and I will generate a income out of it. It's my imagination because I created the application and I'm thinking that my application will work and I will generate a income. For that purpose, I've taken a hell lot of physical servers. Okay, that's the problem here. That is the problem. In the first generation was whatever I've taken the physical server, there will be total hell lot of investment will be involved. Then after to resolve this problem, we got a generation 2. Okay, which is a hypervisor. In the generation 1, right, you can able to run only one application on one physical server. Next after we got a generation 2 which is hypervisor. So hypervisor is nothing but a simple software. What you will do, you will install that software in your physical server. Okay, so hypervisor licensing cost also are involved in addition to OS cost. Now here there are one more thing was got added. You need to purchase this hypervisor license. Okay, in addition to that, hypervisor is just a simple software as I told you, right? Nothing but it's a clone of your WhatsApp. In previously whenever you use WhatsApp, there is a WhatsApp clone application is also used to there. Okay, you can run two WhatsApp in your one mobile, but before that there is you can only run only one WhatsApp, but using this clone feature what you can do, you can run your two WhatsApps or multiple WhatsApps, right, in your single mobile. So hypervisor is also one type of that particular clone of software which you can create a multiple servers, like nothing but multiple clone of your operating system. So for that for that cloning feature, you need to give an amount for hypervisor company, and addition to that you need to pay an amount for OS. If the OS is not free, if the OS, like for suppose if you are using Windows, obviously you need to pay an amount for Microsoft. Okay, so if you see,
Your voice is not audible.
Hello.
Hello, Pawan.
Hello.
hello.
Yes.
Yes, go on.
So from
Go on,
like
Sarathan.
from how many minutes you are not able to hear?
Just 1 minute
Yeah,
until
while
my
you are
question.
trying to explain about the image, right? At that time, we got lost.
Okay, okay. Just a moment. I'm just connecting my charger. Okay. So from this image, right? You missed.
Yes.
Okay, okay. I will repeat this slide. No issues. Right? Generation to hypervisor. So what you will do? You will install hypervisor on the top of physical server, which create a multiple VMs. So hypervisor licensing cost will be involved, right? You need to purchase this hypervisor. Hypervisor is not a free, because there are some companies who provide this hypervisor. Okay, and like for example, there is a VMware. VMware is one of the company which provides this hypervisor feature. Okay, hypervisor is nothing but a same like WhatsApp clone. In your mobile, you are using this WhatsApp application, right? Now you can run to multiple WhatsApps, but in backend it will use a cloning feature called as, using that cloning feature you can able to run the multiple WhatsApp. So before that you used to run only one, like you can able to run WhatsApp on your one mobile, but due to this cloning feature you can run the multiple WhatsApp, right? In the same way, hypervisor also like a cloning, where you can create multiple OSs, multiple VMs. In that, on top of VMs, you can host multiple applications. Now, if you see in this VM, I can run one application. In this VM, I can run another application. Okay, but in the generation one, only one application on the one physical server. But right now, I can run, I can host multiple application. But again, the cost was increased here. On the physical server, you are already investing your amount, but here advantage is you can run multiple application. Okay, still this is also not resolve the problem. Am I audible, right? Then the generation 3 came into this picture, which we will call it as containers. Okay, so container, what is this container? Container is an isolated area created by container engine, which is called, which is nothing but a Docker company, which has a lean OS and application runs inside the container. Okay, what is this container? We will learn, don't worry. Just for now, container is a isolated area, nothing but it's like an ICU, no one will allowed. Okay, which has a lean OS and application runs inside a container. In the ICU, only patient will be present, yes or no? No one will be allowed. In the same way, in this container, the only application will be running. Okay, each container gets an IP address, CPU, RAM. Okay, now if you compare, this is the physical server. Okay, on the top of that physical server, there will be an operating system. In that operating system, you will just install Docker. That's it. Using this Docker, it will create a different containers. Inside that container, your application will be going to run. So what is this container? It's a nothing but an ICU, nothing but an isolated area created by container engine, which has a lean, nothing but thin operating system, and application runs inside the container. Okay, simple meaning. In the interview, if they ask what is this Docker, you know how to tell the Docker. So what is a container? If they ask, container is an isolated area where you can run your application. So nothing but Linux kernel. On the top of Linux kernel, this container will be running. So what is this Linux kernel? All this we will discuss in upcoming days, don't worry. Nothing but, okay, generations of servers. Okay, in the first generation, used to run only one application. Yes, then after in the generation 2, you can run multiple applications. Okay, there is a hypervisor will be involved. Using that hypervisor, you can host multiple applications, but the infra cost will be used. Then after, we got a Docker, which is an open source. There is no cost involved here. Here you can run multiple applications into a different containers. So in the application also, application design also, there are two types of applications, right? Application design architecture, one is monolithic, another one was microservice architecture. So application, whenever creating by developer, right, they need that application design architecture. There are two types of architectures are there. One is monolithic, another one was microservices. Nothing but monolithic, nothing but your total application will be designed, okay, into a one section, and you will be your total application will have a single database. Now my application is working perfectly. Okay, I got a huge traffic. Then if you design your application in monolithic fashion, you need to scale everything. Nothing but I need to take a copy of this whole application into another server. But if you are following this microservice architecture, what you will do here, your application will be designed separately into a different box, different pieces, which call it as micro, nothing but microservices. Okay, what I will do, I will create a user interface as a different microservice, and for this also I have different database. Business logic also I have created as a different microservice. So if I am getting huge traffic for my user interface, I need to scale only this user interface, right? I no need to scale this business and data layer. If you are following microservice architecture, you can scale only user interface, because this is created separately, this is designed separately, this is designed separately. So whenever I get a traffic, I will scale this because I have separate database for this. Okay, if I am getting huge traffic for business logic, I will scale. If you see here, I'm getting huge traffic for user interface. I will scale only user interface related microservice itself. So remaining I will not scale, so that automatically it will be an advantage for me itself. If you are following monolithic architecture, what it will be, I need to do, I need to take the whole application and I need to take it into different server. I need to create a one more server. I need to copy the total application. If I'm getting huge traffic, I need to create a one more server. I need to increase the server. I need to copy the whole application, and it will take hell lot of time. If you are using microservice, what I can able to do, I no need to do copy all application into all servers. I just need to copy the particular component where I'm getting a huge traffic. No need to do for all, so that automatically I'm saving the cost of the company, storage, everything will be automatically be involved here. So the idea of microservices. Let's look at typical e-commerce application. Okay, if you see front end, right, whenever there is a application and there will be a database. This is the basic architecture. So if you see in the monolithic, this is the application. So this is a server one. So there is a payment, there is a product, there is a add to cart. Okay, there are 3 pages in my website. So on one server I will deploy the total application. Okay, this is the server 2, nothing but a copy of this server. So whenever I get a huge traffic, I will be having 2 servers. Now let me show you the microservice. Microservice will be different. I will design separately product, right, add to cart, payment into differently, separately, so that nothing but micro, I'm dividing my application design is totally different, architecture is totally different. Okay, rather than doing all component as a single, I'm dividing into multiple boxes, multiple microservices. So whenever I get a huge traffic for product, I can scale that only product. Okay, no need of scale the add to cart and payment, or obviously it will be an advantage and it will be save the cost of the company. Okay, now let's focus on application tier. Okay, so normally what we have in the application, you will be having administration, you will be having user management, like you need to log in. Okay, you will be having inventories, nothing but your information about on which server it is running. You will be having catalog, cart, payment, notification. So these are the just basic things involved for any website. Okay, so microservices. So this is all about breaking a monolithic to multiple smaller services. I told you, right, rather than designing your total application as a single, you are dividing your application into multiple smaller services. So each microservices generally represent a module which can run on its own. Okay, it can run on its own, nothing but it's a simple module. So smaller changes are possible and replacing services is easier to nothing but now there is a payment service, payment is not working, user came to me that your payment feature is not working, then I can upgrade my only that my payment service itself. I no need to upgrade different services of my application, only this payment service I can able to upgrade it. That thing that like that of flexibility will be available in this microservices, right? Smaller changes are possible and replacing services is easier. So each service can be in different technologies, nothing but I can create the payment service in Python language. Okay, I can create add to cart in Java language. So it doesn't matter that about technology. Each microservice can be designed into different technologies. So if you see why this Docker become famous, Docker was designed for this microservice applications. So if you see, I will run every microservice as a container, payment as a container, notifications as a container, identity as a container, cart, add to cart as a container, catalog as a container. Okay, administration service. If I am getting huge orders, I will only scale that particular order container. I will not scale all items. I will scale only order. If I am not getting huge traffic, I will remove the old container, like remaining container. So depending upon my traffic, I will scale the container. Okay. If I'm not getting traffic, I will just remove the unnecessary containers, so that automatically I'm saving the company's cost, and it is an advantage. That's the reason now companies are, why companies are shifting to this container technology. Now you got it right. So what is that we need to do as a DevOps engineer? So as a DevOps engineer, what we need to do? You need to make your application or microservice run inside a container, right? Using Docker. Ensure we can scale containers automatically. Okay, you need to scale your containers automatically, or it might be manually. You need to enable a CI/CD pipeline to make smaller changes frequently without downtime. If there is any changes, you need to use CI/CD to make the changes, and you should not have any downtime. Nothing but your application will not should not get down. And that's the job of your as a DevOps engineer. So Docker installation. Docker can be installed on any Linux or Windows. Okay. Let's create a Linux VM in any cloud of your choice. Okay. Installation of AWS cloud. First you need to create a key pair. Okay, then you need to create a security group, and you need to log in into that Linux VM. This is the command to log in into a Linux server which you have created in a cloud. So after login into the Linux instance, you can install the Docker by following the official documentation. So after Docker installation, whenever you install Docker, you will get two components. One is Docker client, another one was Docker daemon. Whenever you install Docker, you will get two components. One is Docker client, another one was Docker daemon. Am I audible, right? I just want confirmation.
Yes.
Okay. So how to install Docker, that is a secondary. But when you install Docker, you will get a two components. That is a Docker client and Docker daemon. What is this Docker client? What is this Docker daemon? I will explain with real life example. Don't worry. That is real life example. Okay. In the Docker, there will be a image and container. So using this image only, you will create a container. Okay. Treat this image as a CD. Okay. And in the olden days, if you go back 20 years back, whenever you want to watch a movie, what you used to do? You used to take that CD and you will insert that CD in your DVD player. Like that, you can able to watch the movies. Right? Without CD, you cannot able to. It is not possible. After that, you got a USB port option, that is secondary. Just imagine there is no USB port option. Okay, you need to purchase a CD and you need to insert it. You can watch the movie. Nothing but you need to take a image of your movie, and then only it will be played in your player. Same thing here. Image nothing but Docker image is nothing but CD. Container is nothing but a DVD player where you can run your application. So real life example. If you see, kid is crying for chocolate. So what he will do? He will go to his mom. So what mom will do? Mom will check inside the fridge. Okay, if whether chocolate is present or not. If the chocolate is present, she will give it to the kid because he is crying for chocolate. If the chocolate is not present, what she will do? She will go to the market, right? Chocolate shop. She will purchase that chocolate. Okay, this is what will happen. Yes or no? So what I said, whenever we install Docker, what are the two components we will get? Whenever we install Docker, what are the components we will get? Two components. I told you, right? Docker client and Docker daemon. Yes or no? Am I audible? Hello?
Yes, it's audible.
Okay, okay. So please respond. If you don't respond, it will be difficult. I I thought that it's an issue of mic. Okay, treat this mom as a Docker daemon. Okay, Docker client is nothing but a kid. So Docker client will come to the daemon and it will request for daemon. Daemon will locally will check in the local repo whether that Docker image is available or not. If the image is not available, it will download that image from the Docker hub, from the market. Okay, kid is chocolate is a image. Chocolate is equal to image, Docker image. So when Docker, like what are the Docker commands you will execute, right? It comes under CLI, which is a Docker client, and Docker daemon will act as a mom. Nothing but Docker daemon will run 24/7, same like mom. So whatever I needed, Docker client will send the request to Docker daemon. Okay, Docker daemon will respond for everything. Okay, if you don't understand, remember this real life example. Kid is crying for something, he will ask for his mom. Mom will resolve the problem. Now let me go to next. So let's run hello world container. So basic nothing but hello world simple container using Docker. What is this container? I told you that we will discuss. Don't worry. So to run a container, the simple command was docker container run hello world. Okay. So to run a container, we need a Docker image. I told you, right? In the above command, hello world was the name of your Docker image. Okay. Docker images are available on Docker registry. The default Docker registry is Docker Hub. So the default registry, nothing but which is managed by Docker, it is a Docker Hub. Nothing but it's a factory, a shop. So what happens at high level during container creation? Okay. This is the Docker client. I told you that whenever you install Docker, you will get Docker client and Docker daemon. So whenever you execute any command, the request will go to Docker daemon. Okay, Docker daemon will check locally whether this hello world image is present or not. Because using this image only, container will be created. Without CD, there will be no DVD, right? DVD player's life was depend upon this CD. DVD, right? Whenever you insert that CD, then only in that CD only your main movie will be there. DVD player will just play that movie. In the same way here, container is just a box. Inside that box, if you want to run your application, every application information will be stored in the image. What is this Docker image? What is this container? We will discuss. You just understand the relationship for now. Okay. So for that, first it will check, Docker daemon will check whether that CD is available. Nothing but image is available locally in your in the in that server or not. Right? We'll check if there is a image is available locally. If it is not available, okay, then it will download it from the Docker Hub, which is a public platform for Docker. Okay, then it will download it and it will store in the local system. Then after using that, it will create a using that image. It will create a image. Sorry, you create a container. So Docker client forwards the request to Docker engine, which is a Docker daemon. Okay, Docker engine checks for existing of images locally if the image is present or not. If the image is not found, it tries to download from registry, which is a Docker Hub. Once the image is downloaded, Docker engine creates a container based on Docker image. To download the image from registry, we use pull. Okay, if we create a new image in some machines, To make it available to a repository, we will be using push. What is this pull push? It will be secondary. So next topic, tomorrow's topic, what is this Docker image? I will discuss. Okay, what is this container? What is the difference between this virtual machines and containers? We will discuss in next class, that is tomorrow, that is on day 2 we will discuss. Okay, for now there is a free website is available. So for if you don't have an account in AWS, right, let me show you the factory images shop, right? Mom will go and purchase to shop, right? This is a Docker hub, hub.docker.com. In this there are multiple images will be available. Okay, you can search. Now let me search for hello world image. Nothing but you can treat this website as a movie world. There I can search for multiple movies. In the same way here for applications, right? For application images will be available in Docker Hub. So hello world, if you can see Docker official image, 1 billion plus downloads are there. So for every image you will be having tags. So what is this image, what is this tags, what is this container, we will learn. Okay, for now today's task for you was try to create an account in Docker Hub. If you don't have an account in Docker Hub, click on sign up, give your email and create an account in Docker Hub. Okay, the second task will be there is a Docker playground. Okay, this is the website, free website, where in this website you can log in using this Docker Hub account. Okay, my Docker Hub account username is Devops easy. Continue. You need to give your Docker Hub password. So that's the reason I told you to create a Docker Hub account. Okay, then after you can start, click on start. So what you will do in the playground, you will play, right? In the same way, this Docker playground is also, in this Docker playground you will get a daily 4 hours, right? If you whenever you click on add new instance, it will create a new server. In this server Docker is already installed, so you will get a fresh server with Docker installed on that particular server. It's a free website, it will not work perfectly. Okay, so if you see sometimes it will not work. So that's the reason I told you to create an account in AWS. In that AWS you can create any server. So I will click on add new instance. Okay, close session. I just want you to show some basic container. That's the reason I'm just logging into this playground. Okay, now I got a server with already Docker was installed. I will just enter, alt enter will give you a big screen. Okay, alt enter. Now I will just execute docker info. So I told you, right, whenever you install Docker, what are the two components you will get? Kid and mother, right? Docker client
And Docker Hub.
right, Docker daemon.
Demo.
Okay, you are getting server separate session, client separate session. So what are the commands you will execute? That is a client. Okay, now docker info I have executed. The request will go to the Docker daemon. Docker daemon will give the output here. Now I told you that I will run a hello world container. Docker container run hello world. Here hello world is the image name. Okay, if you see, unable to find image hello world locally, pulling from library. So by default it will go here and it will download the using docker pull hello world, it will download that particular hello world image. Okay, Once it is downloaded, using that image, it will create a container. If you see, to generate this message, Docker took the following steps. Docker client contacted the Docker daemon. Docker daemon pulled the hello world image from the Docker hub. Docker daemon created a new container from that image, which runs the executable that produces the output you are currently reading. So Docker daemon streamed that output to the Docker client, which sent into your terminal. I will run this command again. Docker container run hello world. Now this time it will not download, because in the local system there is already a Docker image is available. So Docker client contacted the Docker daemon. Docker daemon pulled the hello world image from the Docker hub. Image is already available. It is not pulling here. And first time it has pulled, right? And second time it will not pull. Locally, whatever the image is present, it will use that image and it will create a container. If I execute Docker image ls, you can see the image, right? Hello world image is downloaded. Okay, size of that image. For every image you will get a, what is this image, that is secondary, we will discuss. Okay, if you enter alt enter again, you will come out. So once you've done the practice, click on delete. So how to install Docker, that's secondary, we will discuss. It's a simple command. Okay, now I will go Docker install. Okay, Docker install script. Okay, so to install Docker, right, you can download this script, install docker.sh. Okay, then after run this script, that's it, your Docker will be installed. Simple steps. Get.docker.com, in this website you will be having a script to install Docker. Installation will be very easy, you don't need to worry. So that's it for today. Let me stop the recording.